Hi there, welcome back. Welcome to part 3 of the restoration series on this Telefunken Opus 8, one of my favorite brands. I've got a lot of them. This time I wanted to handle the AM section. We did the audio last time. So we know that from the audio forward it's working, power supply is working, audio is working. So AM. How is the AM? How much is needed? What do we need to do? Well, we'll find out on this one, and since I'm doing this at the end, I know what happened. There's a little bit of a surprise mishap for you to watch as well. Maybe you can have a laugh at my expense. I know I do. Right, enjoy it. Well, before carrying on with the AM, I was actually getting a little bit despondent with all the dirt that I was looking at. I decided it was time to do a bit of a cleanup, probably just the parts I was going to work on. But once I started, I got carried away. And you'll see why. This thing looks like it came out of a DeLorean factory. It's shiny, it looks like stainless steel. It came out absolutely fantastically, but let me go step by step. First of all, the knobs. As you can see, they came out, they cleaned up very, very well. All it took was a little bit of warm water and washing up liquid and an old toothbrush. The rotatory antenna indicator got cleaned. No chips, no dings, nothing wrong with these knobs. They look like they came out of the factory yesterday. The piano keys, again, a lot of alcohol, isopropyl alcohol that is, and a natural brush, and a bit of time, and look at the result. Beautiful. I decided to clean the front panel as well. This one was pretty grummy, and I did remove it. I actually removed the panel. There are 2 screws on the other side. That's all it takes. And you can actually wash it out quite well. You can still see some of those sort of brownish spots on there, but I think that just gives it character. I could have painted it, but I decided not to. I wanted to leave it like this. And I'm glad I did, because in place it looks fantastic. Now the actual back, or the top of the chassis, is what really sticks out. This thing is immaculate. There isn't one spot of rust on the entire system. No damage, nothing, absolutely nothing. So once I started cleaning this, I got carried away and just carried on all the way through. I also lubricated the pulleys and that sort of thing. So this is now looking completely different, looking really smart, and I can go forward with the actual restoration with a clean conscience. Excuse the pun. I've said this before and I'll say it again. There's one big advantage doing the cleaning. And I guess I should learn from my own theory and do it more often in that order. I should clean first. Because when you're cleaning, you actually get a very close look at the whole system, right? And look what I've discovered. You see this wire? If you recall, in the repair video I did, that 1-hour repair of this thing, the reception was pretty poor on AM, and I got a closer look. This thing had been ripped loose, so I soldered it on, but I just soldered it on simply. 2 solder points. This thing has got, it's a simple coil, but what I did find was this thing was unwound. You see, this thing comes off here, but there seems to be, you can actually see the other lines where it went to the end. So, and this thing is extremely long anyway. So I've got to remove this and actually just wind it up a bit more and then stick it in place, because this thing is not wound enough. In other words, we've got the wrong number of turns, which means we've got the coil giving us a response that's not what it's supposed to be. So I'm going to desolder this again. It's just the 2 solder points, and wind it up and glue it together. And voila, we are done. I put on the outstanding turns on here. I noticed on the other side there's also 1 or 2 that had come off, and taped it down with that cloth tape, which I like to use. It's almost period correct, and I think that'll make a big difference, and we shall see. Still something wrong here. That's much better. Okay, let me get on with the actual restoration. Well, things are looking different again. As you can see, I decided that besides doing the repair of any of the parts of the AM that needed repair, I wanted to do a little bit of cosmetic work as well. First of all, I decided the faceplate needed to get put on, because if I'm going to do the IF alignment followed by the RF alignment, which I'm hoping to do, I needed the faceplate. So the faceplate got cleaned as well. Again, very carefully, a little bit of soap and water on the front side, very little on the back side, because I don't trust the decals on this thing. Sometimes they just wash off, so you've got to be very careful. And this is the result. It's looking great. It's looking really great. So what did I do on the AM, and what is the result of the testing? Well, wouldn't you like to know? And you'll get to know, but let me show you quickly on the schematic first what we found. It doesn't look that much different. In fact, I've tried to change a bit of the tone of the yellow or the green, and the one I used is this guy over here. And basically what I did is I checked for components that needed checking. Most of them, or all of them, except the capacitors were fine, so the capacitors were replaced. Things like that one there, that one there. Actually, this one had been replaced before. So that one there, if I come down to where the magic eye is, there was nothing wrong with that, nothing wrong with that. I'm just getting things done so that the AM works fine. I followed this line. This is the AGC line, and it goes to all the tubes to adjust the bias and therefore the gain depending on the strength of the signal being received. We can see it going to all the tubes, including over here the FM front end, which is sometimes not handled this way. But yeah, that's basically what we've got. This Ferrite antenna here is the one that I fixed just recently. And I figured that's basically it. I'm finding very little wrong here. These capacitors, this one and this one, they are ceramics, so they're usually fine. I don't replace them. This one here was a paper cap which was replaced, and I forgot to mark that in red. My bad. Okay, this one here, where is it? This guy over here is very important. This is the AGC capacitor. It takes the automatic gain control DC voltage, which is a negative voltage, and this sort of filters it, stabilizes it. And that one was definitely bad. So I think, other than that, I'm ready to show you the results. I have tested it. Spoiler alert, it's sounding great. So I'm going to just show you the results. There's one more thing I need to mention here. There were two capacitors here that I forgot to replace earlier. This one here and this one here. These things that escaped me. This is a 1000 picofarad, so 1 nanofarad. And this acts across the primary. You can see it here, the half of the primary that feeds that tube and the half of the primary that feeds that tube. These two caps serve as, usually you have one, but this is a push-pull, so you have two. And these two caps serve to filter out some of the output. Basically, it filters out some of the frequencies that are not going to be necessary on the speaker system. So above 20 kilohertz, for example. I'm not sure what the actual frequency cutoff is here, but it's usually to cut off high frequencies. And it makes sense. The signal's been generated over here, and it's a very high frequency. It just escapes to the nearest supply, which in this case is B+ over here. And it doesn't get amplified. It doesn't go through the transformer. So that is normal. These capacitors usually are very high voltage rating because the voltage across the primary of the transformer is not limited to the supply voltage. There we go, 245 volts. 250 volts, okay? So you'd expect that this thing would be about 260 or something, but what happens is because of the inductive effect of this transformer, this voltage across here can go much, much higher. In fact, I think the idea is that theoretically it can go almost twice as high depending on how this tube is biased. So you've got to make sure this thing is pretty high voltage. The ones I usually try and put 1000 volts over here. Didn't have them in 1 nanofarad, so I used the 630s, which should be fine. But you do have to be careful with this capacitor. The one they used in here is a 500 volts, whereas most of the other ones are lower. So I think we're ready to test this thing. And if everything goes well, I'm going to feed a signal in here from the mini whip antenna. As you can see, I have not gone through all the coils. I just tested it. I can tell you, I mean, it's working. So I think all these are fine. This was the one that was iffy. It didn't have the right number of turns on there. And so I want to show you the result. Let's get back to it. Right, I think everything's ready. I've got the speaker connected in here. Just this speaker, small speaker, so we don't expect major volumes. I've got the antenna coming in the back there from the mini whip over here. Switch it on. And the dim bulb tester is on as well. So now I'm going to try just medium wave. Those are on. That's drawing quite a bit of current, but remember I've got a 40-watt bulb on there, so you can see it's pretty bright. I know there's no straight short, so I'm going to give it another light bulb. The limiter's now got these two light bulbs on. That's 100 watts between them. Let's see if we hear anything. Yep. Still pretty low, 188 volts. I'm going to give it another light bulb. This is really piss poor. Shortwave. Oh. Now it's early afternoon, so we actually pick up better on the higher frequencies or medium frequencies. This is the 31 meter band. Try the 41 meter band. Oh, there's something I want to show you here. You see here on shortwave, I've got quite a few stations on here, but I can use the band spread function, fine tuning effectively. See the idea? This is down the middle. There's a 0 down there. So I go to the general vicinity and then I can tune around that frequency. So yeah, it's picking up well. Don't understand why this thing is not working so well. Ferrite antenna. Let me go to the Madeiran one. I'm rotating the antenna. It's picking up a little bit better. Oh, I just remembered something. Okay, yeah. Ha! See that? See that? Well, there's a switch on the end of the ferrite antenna rod, and when you rotate it to the end, there's actually a sign on here that says antenna. what it does is it switches out the ferrite and brings in the external antenna. I'd forgotten about that one. Makes a heck of a difference. See, with the external antenna, that's what you get. If I go off it, it receives nothing. Long wave. Don't expect anything really, except my trusty beacon. Let's see if we can pick up one of the others. At night, these pick up very well, including in BBC 4, Radio 4. Oh, here we are. This is something from North Africa. So our AM is actually picking up pretty well. As I said, the time of the day makes all the difference. This is a very early for the medium wave and long wave. In the evening, that's the best. Short wave, as I said, depends on time of day, will determine which part of the band you pick up best. And I just need to do a bit of a check on the alignment. I don't know if anybody's messed with this. I actually don't think so, but just for completeness, I'm going to do that now. Okay, folks, we've had a little bit of a setback. I set everything up to do the alignment, and look what I found. When I put the volume up, I've got this thing on dummy load so we don't actually hear it. See that? That is a massive oscillation. I've got dummy load. If I put that on speaker, it just sounds terrible. So I had to figure out what it was. I've already figured it out, but I'll show you how I did it. I put this thing where it's oscillating, just controlling the volume. And then you take a stick and you start touching things. Now, this thing is oscillating and it seems to be volume related, which means that it leads me to deduce that it's in the audio section, okay? If it was not volume related, it would mean that it would be prior to the audio section, okay? Now, the only thing I did here differently since I tested the audio was those two capacitors that I showed you on the primaries of the output transformer, and that's where I went straight away. Now we're seeing the oscillation on the scope, but if I go here and touch it, it goes away. If I go there, it increases. So I think it's got to do with this capacitor. This guy right here, watch this. This is that one capacitor that I mentioned should be high voltage, and it is close to a ceramic, or rather polystyrene cap over here, which makes the oscillation a lot worse. I think this is the problem. It's radiating, creating positive feedback with part of the audio preamp section. So I'm going to have to remove this cap and put it more in there. You see the other one down here, let's see, the other one is sitting down here and it really doesn't make much difference. But if I go near that guy, see that? So I'm going to replace that cap and see if we get rid of this. Right, I replaced that capacitor and the oscillations went away. That was just a little quick sidestep. I've got everything set up for the AM alignment, IF alignment of the AM bands. What does it take? Well, the procedure is pretty repetitive, so I'm not going to go into all the detail, but generally 460 kilohertz coming out of here. 1 millivolt RMS, 1.4 millivolt, which is the minimum I can get. I've got a 460 kilohertz carrier with a modulated audio tone on it. It's coming out of channel 1. It's going into the switchable attenuator. I can adjust the amount of attenuation I give it because this signal is too hot for this. I need to drop it. At the moment I've got 18 dBs of attenuation. Signal comes out of here. It goes to pin 2 of the ECH81, which is the mixer oscillator. And then the cores I need to adjust for AM are that one and the one below, that one and the one below, that one and the one below. And what I'm trying to get is the highest audio peak, in other words the amplitude coming out of the speakers, And to do that, I've got it going to the scope, but I've also got it going to a AC voltmeter. So I can read the amplitude in the AC voltmeter. Because I've got this thing going through the dummy load switcher, I can actually hear it at the moment. I've got it on speaker. And we can hear it. And the idea is that you make it as low as possible, so you can still discern it as a tone, but you don't get the automatic gain control stepping in. Just a short note, I'm going to leave a link above to the procedure that I did, this exact procedure that I did on the Telefunken Opus 2004, which is basically the same thing. I'm not going to go into all the detail where I explain why and I show you the schematic and everything else. You can go and link up to that. It's I think it's pretty detailed on that one. So it sort of makes this particular procedure something I can do a little quicker. Okay, let me get started. I'm going to put the volume up. I'm just going to switch away from 460, make sure that the noise, or rather the signal that the AC millivoltmeter is reading is actually the tone, not the noise. So if I move away, it drops. Back to 460, the other way it drops. So yeah, I can use this at 460. I can put the dummy load on so we don't have to listen to it. And now I'm just going to adjust these cores, as I mentioned, to get the peaks. Simple as that. First that one. I clean the wax on here. That's going down. Whoa. Whoa, 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 whoa. Okay, that's a peak. That went up quite a bit. Okay, let me just try this one as well. The top. No, wrong way. Oh, it's going down. I'm going to drop the volume a bit. There. Try again. Wrong way. It was practically there. That's a peak. I'll try this one at the top. That is a peak. Now I'll go to the underside. And I've got to do the same thing. So the one I'm doing is this one here. Remember, these things have got to be insulated. You can't use a metal screwdriver. Can't find the thread. Oh, there we go. Okay. There we go. That is a peak there. Oops. That's a peak there. Now this one, the bottom one. Whoa. Very sensitive. I think I'll leave it there. That seems to be a peak. And now this one here. Ooh, wrong way. That seems to be a peak. And now I'll just do them all again. Repeat the whole thing, try and adjust it a bit more. And that's it. That's the AM/IF alignment done. Okay, folks, let me give you a demo of what this thing sounds like in the evening after the AM/IF alignment. So I've got it on long wave. Get the speaker a little closer to the microphone. And let's see, long wave. I can dampen the bandwidth, but listen to that. This is Radio 4 from the UK. It's pretty weak, but I'm getting it. And of course my beacon. Okay, medium wave.
Géneros, espionaje y género negro, que va dejando huella. No hacen nunca bajo ningún conflicto.
En el punto donde está ese mosaico gigante hay unas cuantas bengalas. Está todo para que en 3 minutos empiece este Girondins de Burdeos Paris Saint-Germain.
Cuando está el campo lleno en Francia, que no pase nada.
Ha ligado, ¿eh? Con el sorteo de campos todavía no la ha ligado.
Pude fingir mi propia muerte.
A punto de empezar el partido, Juanma, José.
De una manera bien al aire, del Rayo Vallecano y también.
Okay, see that? It sounds like we have AM medium wave in Madeira. We hardly do. We've got one station in Madeira. The rest are coming from North Africa and Canary Islands. There's one station you hear repeatedly here. This is not image frequencies coming through from the mini whip. This particular station transmits on different frequencies on the various Canary islands. Okay. Now what happens is they have local transmitters, repeaters of the signal on the various islands. And what happens is I'm so far away that to me, 600 miles and 620 miles is the same. So I'm getting them all repeatedly on this, on the medium wave. That's why it seems like this thing's repeating itself. Let's try shortwave. It's amateur band, it seems, 40 meters.
Hier ist Adventist World Radio, die Stimme der Hoffnung. Questa è Radio Mondiale Adventista.
La voce della speranza.
So what I've done is I've set this thing on 41 meters, okay? There's actually nothing there at the moment. Now I use the fine tuning around it, which is this dial down here using the FM tuning knob.
Recovery
after returning to Earth. Shenzhou 12 was the first of 4 crew missions for China's space station.
You see, I can dial these things in a lot more precisely this way. This is obviously amateur band SSB transmission on the 40 meters. Okay, you get the idea. Putting this in the middle.
For COVID-19 every 2 days. We're also pressing ahead with booster shots for these high-risk groups, creating port cities.
Health officials have linked the rising cases.
This is where the lowering the bandwidth makes quite a difference to fine tune.
To 20 provinces, crossing overnight.
Au large de la côte ouest de la Libye, selon un nouveau bilan établi ce samedi.
This is a level 2 disaster, which national disaster management agencies will lead. I've chosen solutions called today, working also with our Christian team, trying to see how best we can support the injured and also play our role in
So yeah, that's pretty amazing. Now, this is really not a surprise because this thing has got the mix oscillator over here, ECH81, which most of these radios do. It's got an IF filter. It's got an IF amplifier, an ECH89, EF89. And then it's got another IF filter, okay, another IF amplifier, and then it goes to the detector circuit. So this thing has got an extra filter and IF amplifier. Most of the cheaper radios only have one of these and one of those, okay? If you look at the Da Capo that I just did recently, you'll see you've got the same IF mix oscillator, you've got one IF filter, you've got one IF amplifier, and then it goes straight to the detector circuit, which is actually in the same sort of box with the EABC80 tube in there, but it's the same filtered, or rather screened circuit in there. So it misses these two. This just gives it more the ability to clarify, to increase the sensitivity and the selectivity quite a lot more if you've got a double filter amplifier in there. So this thing is really a high quality set, which I knew already, but when you hear this, and especially in the evening, this is now in the evening, the difference is incredible. I don't think the difference was so much the IF amplification or the IF alignment that I did, and that one was slightly off. I think it's got more to do with the fact that in the evening, where I am, is when I get most of the AM. I think that's the same for everybody else. So yeah, I'm really pleased with this section, and I think I'm going to leave it off for now and get back to you when I've got the FM. I don't even have the FM tube in there. When I do the FM, and I've got the FM to do, I've got its alignment, I've got the RF alignment for the AM and the FM to check. I need to see what's happening with the Magic Eye. I've got a spare one, which I received. In fact, I received this one for the Da Capo, and I haven't put it in yet because I figured this one might need it just for testing. So I'll be checking that as well. And there are still quite a few things to do. So I think I'll sign off for now, and thank you for your company. Hope you've enjoyed that. Hope you've learned something. Don't forget, if you want to see the detailed description of the IF alignment and why and how, go to that video I linked. It's the Telefunken Opus 2004. I think it's video number 4. And there I go into this detail ad nauseum. The radio is very, very similar in terms of the setup here. So if you need to refresh your memory on that, by all means, go see that video. So once again, thanks for watching. Hope you've enjoyed it. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links are in the description below. So thanks for watching. Bye for now, and stay safe.